Hello students, welcome back to the channel. So today's topic that we are going to study is one of the important topic, that is the diagonalization of the matrices. So before going to what is this topic, we have to know what is a diagonal matrix. So in easier terms, if I say diagonal matrix is nothing but it is a matrix with the square matrix, that is of n cross n, 4 cross 4, 3 cross 3, 2 cross 2, where only the diagonal elements are present and rest all the elements are 0. Okay, if I consider this C1 0 0 0, C2 0 0 0, Cn, so where you can see only the diagonal elements are present and rest all the elements are 0. So that is what is the diagonal matrix. So the topic that we are going to see today is what is called as diagonalization. So when I say diagonalization, a matrix A belongs to R n cross n. It is a square matrix, is a diagonalizable if it is similar to diagonal matrix. Diagonal matrix, we know what it is. We have only diagonal elements, rest everything is 0. That is, if there exists an invertible matrix P belongs to R n cross n such that D is equal to P inverse of AP, that is D is diagonal, and P is nothing but, here P is nothing but we call it as a modal matrix. Okay, so in order to understand deeply and correctly, let us solve one problem and let us understand how to get this diagonalization of the matrix. So this is the problem will look something like this. Find the matrix P corresponding to the matrix. We have a 2 cross 2 matrix. Let's take a simple example of 2 cross 2, and they're asking if to verify if P inverse AP is a diagonal matrix. Okay, the first and foremost thing that you have to do is you have to check whether we have a characteristic equation. We have to solve for it. Basically we need two things, eigenvalue and eigenvector here. So in order to do that, we have to have the characteristic equation, that is A minus lambda I, determinant of that is equal to 0, where lambda into I is nothing but lambda into the identity matrix. So these are all the things we know, so I'm just skipping this part and directly writing it. So it is 1 minus lambda 2 3 2 minus lambda, determinant of that is equal to 0. Now we have to solve this, multiply the terms, 1 minus lambda, 2 minus lambda, minus 3 into 2 is 6, so is equal to 0. So when I solve it, 2 minus lambda minus 2 lambda plus lambda square minus 6 is equal to 0. Solve it, lambda square minus 3 lambda minus 4 is equal to 0. So this is called as characteristic polynomial. Okay, characteristic polynomial. So from this characteristic polynomial, we have to find what is called as a roots. Okay, so we are going to find the roots. All right, so once we have done this, we have to do our traditional method, that is the factorization method. Lambda minus 4, lambda plus 1 is equal to 0, lambda minus 4 is equal to 0, lambda minus 1 plus 1 is equal to 0. So lambda is equal to 4 and lambda is equal to minus 1. All right, so these are nothing but our eigenvalues, that are minus 1 and 4. So the first part is done, that is finding the eigenvalues. So from these eigenvalues, we have to find something called as eigenvectors, which is usually represented by x is equal to x1 comma x2. So let us find out this. So what we have to do, we have to find we have to use these eigenvalues and we have to find the eigenvectors. So case 1, when lambda is equal to minus 1. So what is the formula for it? It is nothing but determinant of A minus lambda I into x is equal to 0. Okay, so here it will be determinant. So A minus lambda I, we already have this, 1 minus lambda 2, 3 2, it's 2 minus lambda. What is x? It is x1 x2 is equal to 0 0. Okay, 0 0. All right, now what we have to do, we have to substitute wherever you see lambda, we have to substitute with the minus 1. So since I have the values directly, I will substitute. It is 2 2 3 3. Okay, you can pause the video and check for your own. So x1 x2 is equal to 0 0. All right, after this, what we have to do is we have to write the equation. So it is 2x1 plus 2x2 is equal to 0. Then second equation will be 3x1 plus 3x2 is equal to 0. So this will be equation number 2 and equation number 3. So equation number 1 will be the equation where we got our characteristic polynomial. All right, now you can take any of the equations you want to solve. So let me take equation number 2. So that is nothing but 2x1, let me write it down, 2x1 plus 2x2 is equal to 0. So here we are seeing some common element, that is 2. So we are going to divide it by 2. So x1 plus x2 is equal to 2. So let me take x2 to the other hand side. So x1 is equal to minus x2. So whatever the coefficients that the x1 and x2 are having, we are going to bring down to their denominator. So what is that? So we are going to write x1 divided by minus 1 is equal to x2 divided by 1. So that will be the value of x1 and x2. So that is x1 is equal to minus 1 and x2 is equal to 1. So this will be my first eigenvector for the value of eigenvalue, that is lambda is equal to minus 1. So let me write it down as x1 x2 is equal to minus 1 and 1. So this will be my first eigenvector. Now let me do the same process for the second eigenvalue, that is lambda is equal to 4, and let me find out the second eigenvector for lambda is equal to 4. Okay, so what I'll do is directly I will substitute the value, that is minus 3 2. So I've directly substituted the value of 4 to the equation. You can here again pause the video and check on your own. So this is the equation I will get. Now I will write the polynomial equation, that is minus 3x1 plus 2x2 is equal to 0. 3x1 minus 2x2 is equal to 0. Again, name the equations are 4 and 5. You can take any equation as per your wish. I will take the fifth one, that is 3x1 minus 2x2 is equal to 0. So let me take 2x2 to the other hand side. So we know what we have to do. We have to write the coefficients to their denominator. So it is x1 divided by 2 is equal to x2 divided by 3. So x1 will be what? 2 and x2 will be what? 3. So now we have the second eigenvector for the eigenvalue lambda is equal to 4. So once that is done, we are knowing that okay, this is our second eigenvector, and we already have our first eigenvector. So these two are, it's handy, right? So we have the two eigenvectors for the eigenvalues. Now what we have to do is we have to construct a modal matrix, that is P. So how we are going to construct the modal matrix P? These are nothing but the values of the two eigenvectors that we have already got. So that is for lambda is 1 is so lambda 1 is equal to minus 1 and lambda 2 is equal to 4. So I'm going to write the values of the first eigenvector and the second eigenvector in this way. So that is nothing but our modal matrix P. Okay, so when we write the equation D is equal to P inverse AP, we already have P now. We already have the A. Now what we want is something called as the P inverse, that is the invertible matrix. So how to find out that? So it is P inverse is equal to adjoint of P divided by the determinant of P. Okay, so finding the determinant is very easy. So first we will do that. So find the determinant of P of the square matrix minus 1 1 2 3. It is nothing but you have to multiply each of the diagonal elements. So minus 1 minus 3 minus 2 is equal to minus 5. So determinant is minus 5. So let me write it down. So it is nothing but P inverse, right? So P inverse is equal to minus 1 by 5 minus 1 by 5. How to find the adjoint P, right? Adjoint. So it's adjoint. P is nothing but the matrix we have, that is minus 1, 2, 1, 3. So in a 2 cross 2 matrix, it is very easy to find the adjoint. You just have to interchange the diagonal matrix, diagonal elements, that is minus 1 and 3, interchange them, and you have to change the signs of the elements, that is 1 and 2. okay, in a 2 cross 2 matrix. So let us do that. So it is minus 1 by 5. So what you have to do, you have to interchange the diagonal elements, right? It is 3 and minus 1, and you have to change the signs of the rest of the elements. This is minus 2 and minus 1. So now it is very easy for us to find. So we have I will not solve it, okay, I will keep it as it is, then we will do it in the further steps. So let me take the minus sign inside, so that rest of the minus cancels out and we have the P inverse now. So what is this step we have to do is P inverse AP is equal to diagonal. That's what we have to prove. So let me take P inverse AP, P inverse AP, and let me do the solving part. So it is my 1 by 5 minus 3 2 1 1, and the A matrix will be nothing but 1 2 3 2, and we have the modal matrix P, that is nothing but it is minus 1 2 1 3. Okay, multiply the A and the P first, and then we'll go for the second one. So it is 1 by 5 3 2 1 1. So when I multiply, it's first row first column, first row second column, and it goes on, right? So this is a basic matrix multiplication. So minus 1 plus 2, 2 plus 6, minus 3 plus 2, and 6 plus 6. So I will get the matrices as 1 by 5 minus 3 2 1 1, and I will have the solution part will be 1 8 and minus 1 and 12, right? So again we will do the multiplication of the first and the second matrix, that is similarly the first row first column, first row second column. So I have the solution ready with me, that's why I'm writing it very quickly. You can pause the video and you can check on your own. So what I will do is I'll simplify this. It is minus 5 0 0 and 20. So now I will multiply the 5. So I'll get minus 1 0 0 and 4. So first and foremost thing, you have to check whether it is a diagonal matrix. Yes, it is a diagonal matrix because I have only the diagonal elements. Rest all the elements are 0. Yes, the first condition is proved. It is a diagonal matrix. Now how to check whether you are right or you have solved the problem correctly? So if you see the elements, they are nothing but your eigen values, right? So see the eigen values are minus 1 and 4. So what you have got in the diagonal, you have got that in the diagonal you have got minus 1 and 4. So you can now clearly say that yes, you have clearly solved the problem very well, and it's a kind of a shortcut to, or a tip, you can call anything. So this is how you prove that you are having a diagonal matrix and whatever you have solved is right. So this is a simple tip for you guys. You can use it in your exam. It will be very easy. So next time you will solve 3 cross 3 matrix. Thank you.